In this video, I'm going to show you how to use a spec-20 to make measurements. So the first thing we need to do is we need to blank the instrument. We need to tell the instrument what 0 looks like. So this is just a sample of deionized water. Okay, that means it's just water, plain water. Because you notice right now the instrument is reading negative 0.07. So we want to tell the instrument what 0 looks like. So this is what the inside of the instrument looks like. We take our cuvette and we place it in so that the little notch is pointing that way. We close it. We've already set the wavelength to the wavelength we want, so now we just hit 0. And then the instrument takes a reading, and it's saying, okay, this is my baseline. So now the instrument knows what 0 looks like. So we wait patiently. Okay, now the instrument says, all right, here's my baseline. That's what plain water looks like. So now, when I take my sample, I take my blank out, I put my sample in. Now one of the things you always want to do, look at all those bubbles. Okay, you want to tap the sides to get those bubbles out. Because if you have bubbles in there, those bubbles will mess up your reading. Okay, so you tap the sides, and then you also want to use these little Kim wipes. Wipe down all the fingerprints from the exterior. Now this is just food dye, right? So it's non-hazardous. If it was something hazardous, obviously I'd be wearing gloves. Again, you want to put it in with the notch facing that way because the emission source is over here, the light source is over here. Close. And now it's giving me an absorbance. So the absorbance of that sample is 1.12. So now let's talk about how you would analyze that data. So you're going to make yourself a graph using Excel. Okay, you're going to plot concentration versus absorbance, where the concentration is a percent. So in our lab today we did 25, 50, 75, and 95, plus an unknown. You plot concentration and the absorbance value, and you should get a pretty straight line. Maybe not perfectly linear, but pretty close. And then, using the instructions I gave you on Excel, you can add the trend line. So the trend line gives you y equals mx plus b, right? The slope-intercept form. So in other words, y is absorbance, right? So that's the y variable. M just stands for slope, so that's the slope of this line, so that's the rate of change. We're really not interested in that today. X is the concentration, and then b is just the intercept. Okay, so let's pretend that the unknown had an absorbance of 1.13. I think the one we just looked at was pretty close to that. And I want to know what's the concentration. So how would I do that? I would just take this value, 1.13, and I would plug it in. Now, do I plug it in as absorbance or do I plug it in as concentration? Well, that's an absorbance value, right? So I'm going to plug that in as my y value, right there. And then the slope, that's given to me by my trend line, so that just goes directly straight there. And then the intercept, that's given to me by my trend line as well. So now all I have to do is solve for x. So I plug my absorbance in as my y value. Using the slope and intercept given to me by Excel, I can then solve for concentration. And it will be in units of percent because that's the unit of my concentration in here. If my unit had been in molarity, then obviously my concentration would be in molarity. But this is how we do a trend line. This is the purpose of a trend line, is to help us figure out the concentration of an unknown by absorbance. Also be sure to check out the video of the pre-lab discussion where I explain the theory of how the spec-20 works.